Hey guys, here's the second behavioral health lesson. Today we'll be covering an introduction to science and how that's applied to psychology, research in psychology, correlational methods used in research, ethics in research, and interpersonal relationships with the psychologist. So first, what is science? A basic definition is that it's a systematic knowledge acquisition through structured observation and experimentation. with and you're already exposed to this in elementary school and high school via the scientific method that you apply in all your science exploration labs. And that's to account for objectivity, which is basing conclusions on facts and not personal bias. Let's take a classic example. Many psychologists will employ objective study to measure the effects of food additives on children's behavior because they need to provide guidance for parents and the food industry. So, the question is, how can scientists measure a child getting out of control after eating too much sugar? Right? What tools can a scientist use? Because there's two biases that can occur. One is from the researcher, and one is from the child. So uh, the procedure is called a double blind, and what it does is it controls for placebo effects in which neither the participant nor the experimenter observing the participant knows whether they were given a real sugar or fake sugar. And that fake sugar would be a placebo. It's an inactive substance or treatment that can't be distinguished from the active substance. So it has to look and taste exactly the same. So the first part is that the participant is blind. So in the image, we can see that the fake sugar cubes are not quite as convincing. And for example, if the child realizes this, then they won't entirely be convinced that they were eating a real sugar cube, which might lead to things like disappointment. And then the placebo effect cannot be accurately measured, and the child might not get out of control because of the poor placebo, and they might actually become more calm or studious. Right? That's a bit of a stretch, but it captures the essence of what a placebo should not be. So, what should a placebo be? It's supposed to offset expectation biases. For example, coffee is perceived as something that can boost your alertness. So, if you are given a placebo for coffee, then that should also be able to uh, fool the participant into thinking that it is coffee, such that if they simply expect coffee to boost their alertness, the fake coffee can also make them do that simply because of their belief. Now, that ensures that changes are due to the specific treatment itself rather than the participant's belief, right? And that controls for psychological effects of expectation. The second part of double-blind research is that the researcher themselves have to be blind. This is important because the researcher is ultimately the one making the observations and making the conclusions. So how can they make sure that they also don't have a bias? Well, they also can't know who receives the treatment or the placebo. And so then you avoid the influence of expectations on observations and conclusion. For example, if a researcher is measuring the effect of an antidepressant and they know that they are giving a patient the actual antidepressant being studied rather than a placebo, that's problematic because they may convince themselves that the patient is displaying a signs of improvement even when they are not. Second, how do psychologists conduct research? The first method is a case study. It's an in-depth investigation of an individual or a small group. It's valuable for unique or rare cases that offer insight to a phenomena. It uses interviews, tests, and sometimes also uses brain imaging for data. A very a very famous example is the case of Henry Molaison, who's more commonly known as in the field as HM, whose case study of the hippocampus revealed memory formation processes. The only limitation is that, first of all, it will take quite a lot of effort and time in some cases, and it's hard to generalize findings beyond individuals. For example, if your case is too special, then you might not even be able to know if it's applicable to the general population. This is its a positive and also its downfall. For the case of Henry Molaison, essentially he was a patient with severe epilepsy, so they did surgery on him to cut out his hippocampus. Originally, everything was fine, but then they realized that he could not form new memories, and even 20 years later, when he woke up and looked in front of the mirror, he was convinced that the person in front of the mirror was not him. He was convinced that he was supposed to look like his 20-something-year-old self that's displayed in that image there. The funny thing is, because he couldn't form new memories, those thoughts only stayed for a few minutes. So while he was very scared of the unexpected face in front of the mirror, give him another 5 minutes and he'll forget that he was ever concerned in the first place or that he even looked at the mirror in the first place. Another interesting thing about Henry Molaison is that we also know that the hippocampus is not where memories are ultimately stored, because he was able to learn how to drive and even play the piano and even learn how to play the piano. However, with the lessons that he ultimately lost the memory of, after the lesson, he was still able to play even though he had no recollection of those guidances ever happening. Second is a naturalistic observation versus controlled experiments. A naturalistic observation is the observation of behaviors in their natural environments. The most famous case is Jane Goodall. For controlled experiments, that would be manipulating variables in a controlled setting like a lab or a clinic. Unfortunately, with both of these, observation has what's called the Hawthorne effect, which is that if the participant knows that they are being observed, they may alter their behavior. For example, if you are conducting a review of the efficiency of people working in a factory, if they know that they are being reviewed, then obviously they will start to work much more efficiently, and that will not be very telling of the actual productivity that's going on when they are not being observed by their boss. The third is surveying. This collects data quickly from a large group on attitudes or behaviors. It's often anonymous or confidential to increase honesty, but also to maintain ethicalness. The limitation is actually also lies therein as well, because people might lie or give socially desirable answers. It relies on self-reporting, and accuracy varies with question sensitivity. So if you give a very sensitive question, whether the participant knows it or not, they might respond in a certain way that's not actually true of their own identity. It's useful for preliminary insights and identifying large trends. For example, the PHQ is often used as a self-diagnosis for depression. Many researchers use this to study depression in a large trend. For example, what the effect of virtual schooling is on mental health, which was quite a prominent research topic when COVID-19 was the most prominent. For cross-sectional research, the most common example is with age. So it observes different age groups at a single point in time. It's like a shot. So it compares groups to identify age-related differences. The limitation is that the cohort effects may confound age differences, right? The people that you select in your group maybe they're not just equal in terms of age. They may also be equal because of some problems in your selection process, right? So it's efficient, but it may not accurately track developmental changes. It's useful for establishing baseline differences between groups. The complete opposite of cross-sectional is longitudinal. That follows the same group or person over a long period of time. It tracks individual changes, so it reduces cohort bias because with all the traits that you must consider, you'll be investigating all of them. The limitations are that it's very expensive, it's time consuming, and it's prone to dropout. So if you have a few participants, right, for a longitudinal study, and one of them drops out, well then their previous data is not usable anymore because you don't have the rest of their data, and now you'll have to restart with a new participant anyways. It's a strong method, however, for studying developmental changes. Third, correlational methods. So here are three terms. An independent variable is an experimental variable controlled and manipulated by the experimenter, for example, whether or not a child has consumed sugar. The dependent variable is an experimental variable that measures and demonstrates the effect of the independent variable. For example, whether the child becomes collected and calm or whether they become crazy and over the top and overly energetic. A control group is a group that experiences everything that happens in the procedure except for the treatment of the independent variable. So in order to study the effect of sugar and sugar only, there will have to be another group. Have to be another group of participants that don't consume the sugar at all to measure the baseline difference of what's normal and what happens to the children after they consume sugar. So we've already talked about the experimental group. Now, the random assignment is quite an important consideration when designing a research project. So it's a procedure in which each participant has an equal chance of being assigned to any group in an experiment. So if random assignment is successful, then there should technically be no other biases that affect the research. This is the problem that they focus on with cohort bias. So ideally, it should not happen at all in cross-sectional research, but it can if random assignment is not able to be utilized to its full extent. A confounding variable is a variable that is irrelevant to the hypothesis being tested, and yet it can alter the researcher's result. For example, if one participant exercised right before they took right before they consumed the sugar cube, they might feel fatigued even though theoretically the sugar should make them feel temporarily energized. And number four, how researchers draw conclusions from data. Now, here are two important terms, not just for behavioral health, but for psychological studies in general and science in general, which is validity and reliability. So first, validity. It's meant to measure the accuracy in representing the intended concept. There's construct validity, content validity, face validity, criterion validity, internal and external validity as well. For construct validity, that asks the question, does the test measure the concept that it's intended to measure? Does a self-diagnosis questionnaire of depression actually successfully diagnose a patient with depression? Content. Is the test fully representative of what it aims to measure? Face. Does the content of the test appear to be suitable to its aims? And criterion. Do the results accurately measure the concrete outcome they are designed to measure? And internal versus external validity is like the causal relationship, not being influenced by confounds versus the generalizability of the data to other groups or situations. So in one phrase, validity would be results satisfy the objective. Second is reliability. So with reliability, that's the consistency of measurement outcomes, and there in the large brackets, that should say external reliability, not external validity. So there's test-retest, inter-rater, inter-method, and internal, which is opposite of external reliability. So test-retest is the consistency of the same test over time. Inter-rater is the reliability of the same test conducted by different people. Inter-method is whether two or more different measurement approaches capture the same phenomenon. For example, is your PHQ depression questionnaire actually telling of depression when it is controlled, when it is compared to standards like clinical diagnosis by a practitioner? Internal reliability is whether multiple questions or items on an assessment that are supposed to measure a single concept actually measure a single concept and review and yield similar results. For example, all the questions on the SAT math section are relatively similar level and are closely related in terms of question type. So a person who is good or bad at math should not be fluctuating between uh, getting lots of correct answers and lots of wrong answers, right? It should be consistently relatively in their skill level. So in one phrase, reliability is that results are consistent. Here are some other terms for statistical analysis that are introduced to you already. So the mean is the numerical average of a set of scores. You add them up and you divide them by the amounts of data in the set to get the mean. The median is the halfway mark in a set of data, which you obtain by ordering the set, and half of the scores are above and half of the scores are below. The mode is the most frequently occurring score in a set of data. If there is only one of each, then there is no mode. Now, variability and standard deviation. Variability is how spread out scores are from each other or to their mean. It's often measured using the standard deviation, which is a measure of variability. So it's how tightly clustered the scores are around the mean. You can see that there are two graphs with medium variability. It doesn't matter where actually the range of the graphs are. It just matters that it doesn't matter how high or how low the data in general is. All that matters is how closely are the data spread out. And we also have a term called negative skew and a term called a positive skew. So with a negative skew, the mean is less than the median, which is less than the mode. And with a positive skew, the mode is less than the median, which is less numerically than the mean. So it's actually slightly counterintuitive. And the normal curve is something that you need to remember in terms of the standard deviation. All that you need to remember for behavioral health with the normal curve is that 68% of scores will fall within one standard deviation of the mean. 95% fall within two standard deviations, and 99 fall within three standard deviations. This is the basics of population trends in psychology, and that's how they measure it. So you won't have a perfect normal curve in real life studies, but sometimes you get something quite similar. Correlation coefficients, they measure the relationship of strength and direction. So it ranges from -1 to 1 with 0 indicating no correlation. The stronger relationships are are closer to -1 or +1. Positive correlation means that the variables increase together, while negative correlation means that uh, one variable increases as the other decreases. So positive is like a positive slope, and negative correlation is like a negative slope. However, I will point out something on the next slide, which is that positive and negative correlation, they don't actually look at how large or the specific value of the slope. They just look at whether it's positive or negative. And then as for the actual numerical value of the numerical absolute value of the correlation coefficient, that actually is just determined by how close the data points are to a linear relationship, right? So a perfect negative relationship is demonstrated to the left, and a perfect positive relationship demonstrated to the right. It's not as if these lines are getting steeper and steeper. It's just that with the perfect correlations, they are perfectly linear. This will also not happen in research. If it does, your procedure is likely wrong. Now, descriptive statistics versus inferential statistics. Descriptive statistics measure uh, and summarize and organize data to reveal patterns, such as calculating averages, while inferential statistics takes what's there and then extends that conclusion from sample data to larger populations, which allows for generalizations or inferences. Now, finally, we'll talk about ethics. So first is informed consent. The consent is obtained from a research participant by providing them a thorough explanation of the risks and benefits associated with the experimental procedure. With Stanley Milgram's experiment, this was before the days of review boards, which is why the authorization for his experiment would not take as much work as it would now. In fact, it probably would not be able to pass the check. For approval, you go to institutional review boards for human participant research and institutional animal care and use committees for animal investigations. Now, for ethical research principles, we have no coercion, informed consent, no harm, confidentiality, and privacy. With animal subjects, you have necessity of the research, right? Are all the things that we're doing to the animal actually necessary to study? And are all the things in the procedure designed specifically to measure for the purpose of the research question or topic, right? The animal subjects have to have excellent food, housing, and veterinary care. This is elaborated slightly with different review boards and committees for the animal care research, but uh, there's a bit of a gray area with that. And also, there should be minimal pain and suffering. With humans, it's no harm, and with animals, there's minimal pain and suffering involved. It's okay. Now, even with humans, there are a few exceptions. So it is actually okay to, for a stage in the research, deceive the human into believing that an experiment is not actually what it ought to be. For example, with the Hawthorne effect, right? If we go back to observational research, if the participant knows that they're being observed, then they will act differently. So in order to maintain that, you actually don't tell the participant until after you've collected all the data, right? And then you tell them the actual goal of your research. But by this point, if they want to opt out, they opt out and you don't use their data, and that's totally fine as well. So if you have any questions, please leave them down in the comments below, and I'll see you next week. Thank you.